Okay, what I'm going to talk about today is an annular solar eclipse. In my opinion, an annular solar eclipse is one of the prettiest eclipses around. What we basically get is we get a smaller than normal moon. In a normal case, the sun is 400 times larger but 400 times farther away. Moon is 400 times closer but 400 times smaller. And because of that, their apparent size in the sky should be almost exactly the same. In this case, we're getting a farther than normal moon away from the Earth, which I'll explain geometrically a little later. But the moon actually is close to the sun, called perigee, and farther from the sun, called apogee. This is an apogee moon. About a month ago, we actually did have what's called a supermoon, where the full moon was actually closer to the Earth because of its elliptical orbit. If it's close to the Earth on one, it's got to be farther away from the Earth on the other. In this case, we had a farther than normal Earth back on May 18th, 2012. I was not able to cover the entire limb of the sun, and I'll show you that picture in a little while. Okay, this picture is showing you the geometry, as well as this one, the geometry of a solar eclipse. I talked about in another video, if we actually have a perfect eclipse, have a perfect alignment, what we get is we get the ecliptic, which would be like right here, straight line. We get the moon is about 5 degrees up or 5 degrees below. It does intersect at what's called the node right there. If I picked a different color, actually here, I can show it on this one. The moon goes around us in a counterclockwise direction, which means basically that didn't want to do that. I want to get a different size brush here. Trying to look for a 2. So the moon's going around in a counterclockwise direction, going around in this direction. What that basically means is that it's coming this way around, and when it crosses this, it's called the descending node, where it crosses our orbit. And then when it goes around this way, going around the other side, it is the ascending. And we get that with planets as well. And we're going to have a transit of Venus happening Tuesday, this coming Tuesday, which is the 5th of June, 2012. I did a video on that, which is posted earlier today. Here's another one where we actually get the moon going actually right through the middle of our umbra, the darkest part of our shadow. That gives rise to what's called a total lunar eclipse. What we're going to get Monday, June 4th of this year, we're going to get a partial eclipse where it's actually going to go a little bit above instead of below, but it's going to go a little below that. But this is a lunar eclipse, but we get the basic same chemistry. Here's the geometry of a solar eclipse. We have to get the sun, we have to get the moon, and we have to get the Earth all in a line. So the moon's node has to line up with the Earth. The sun has to be right below it. We do get this thing happening all the time, but it has to happen at a new moon to cause a solar eclipse, or on the other far side, a full moon to cause a lunar eclipse. Here's an example of, and I will tell you that almost any time you see a diagram, they're not in scale. This is not in scale either. If you actually looked at the moon's orbit, it would be almost circular, and probably more circular than any man-made object, more round than a bowling ball, but it's not perfect. On average, the sun is 250,000 miles away from the Earth. It gets a little farther at what's called apogee. That's when we get this annular eclipse. It gets a little closer when it's called perigee. That's when we actually got that supermoon about a month ago, full moon. This full moon is going to actually go, like I said, going to go into a partial lunar eclipse. So here's the geometry of these eclipses. If the moon can actually go in front of the sun, which it does all the time, it has a shadow, and if you can be located right here on this shadow, you can be a total eclipse. Whether it be the moon shadow, it would be a total solar eclipse, or the Earth shadow being a total lunar eclipse. But if you can be inside this umbra, I don't know why I'm doing it with the mouse, umbra, or the penumbra, umbra is totally blocked out, can't see any part of the sun. The penumbra can see a little bit of the sun, so it's not quite as dark. If you're in the penumbral part of the eclipse, it's called a partial. If you're in the umbral part of the eclipse, it's called total. Very small band going across. The other part, the penumbra, is a little wider. But then, if we get a smaller than normal moon, what we get is what's called an annular eclipse. Here is the supermoon. So this would be a super full moon. This would be like the mini moon. If we get a super full, that equals a mini new. And if we get a mini full, that's going to equal a, if that's possible, a super new. So we had a super full moon back toward the beginning of May, so we are going to have a mini new moon to actually give us this partial eclipse, or this annular eclipse, which is that picture up there. Okay, here's what a total solar eclipse looks like. Again, it is a totally cool eclipse. The moon covers the entire surface of the sun. Then we get to see the corona going out. If you ever see anybody draw the sun like this, they're drawing the corona, even though you can't really see it. When the sun's there, it's not near as bright. Here's a partial eclipse where the moon's moving like this direction across and just slowly carved out a little piece of the moon, and then eventually it's going to pop out the other side and the sun will be normal. This is the one that's going to actually happen on June 4th. You can see that the orbit is way up here, so it's going to actually take it through part of the umbra, but in the penumbra, this is going to be the partial eclipse of June 4th, 2012. Here's a picture of another one. This one I think was in 2005. I'm going to show you a video of the whole thing. It's going to come from this site. You can see this is from M. Armstrong. This is the annular eclipse of October 3rd, 2005. And here it is. You can see the moon moving down. It's smaller than the surface of the sun, apparently, so it actually lets a little of the sun go out, but it's going to pass through. And we'll watch this one more time. You can see it coming in, actually touching the outside of the sun, goes over, and because the apparent size is smaller, you get to see a little of the sun all over. So it looks like that. Let me see if I can find, got too many things open here. It's not Prezi, it's not this one, it is this one, I think. Here's a picture of Venus and Mercury actually heading toward the disk for the SOHO satellite. Sun being right there, so you can see it's actually going for the transit. Where is that picture of the sun? There it is. So here is a picture of, I guess you can't see all of it because the camera's not going out there. Here's a picture of it. It's coming from Astronomy Picture of the Day from January 22nd, 2010. Don't know exactly what the date was. Let me see if it actually says down there. This was on June 15th, 2010. This supposedly is the best picture ever, highest quality. You can see the granation of the sun in the background. Thank you much for joining me. We'll see you soon. Bye.